circuit, three types. One is the base bias. Second type is the emitter bias transistor. And the third type of transistor circuit is voltage divider base the transistor. So now we have already learned before. So today we're gonna learn about the emitter of the bias. Okay.
We just started talking about that the other day.
Yeah. So now I'm gonna drawing for the emitter, but I think I have already, the share with the printout, right? Just like page 25. But if you're missing, please let me know. I'm gonna reprint for you. Okay. So that is V sub CC, and that was R sub C here is for collector C. Okay. And that was R sub E here, the register for the emitter. And compared to the base biased transistor, for this case, they do not have a register of the base part. Okay, that is the emitter part here. All right, so that is the voltage supply, the base part. That is a voltage supply, the collector part here. Okay. So we learned before the emitter bias, the transistor circuit. So V sub BE, second approximation, 0.7 volt, right? And V sub BE is equal to V sub B minus V sub E, V sub B minus 0. Why? Because they have 0 to the ground here. Okay. So the V sub B is equal to V sub BB. Okay. And also V sub E is equal to V sub B minus V sub BE. Okay, because V sub BE, the voltage, has the potential difference between the 2 points, the B, the base, and E, the emitter side. So V sub B minus V sub E. Okay, so this is why we can explain this one here. All right. So, and also still keep going. And I sub C, so really similar to I sub E. Do you remember in the base bias transmitter circuit, I sub E is equal to I sub C plus maybe I sub B. But the I sub B is very small, the current for the I sub B for this case, okay? For this case. So each formula to find the part is different from the each case, okay? Don't confusing, okay? All right, so right now, so I sub C is almost same is equal to I sub E. And what is V sub C? So the V sub C right there, let's say like this one, V sub C is for V sub CC minus I sub C times I sub C. So it means V sub CC minus V sub I sub C here. Okay, just right there. Here. Gonna write this one. Okay. So And then V sub CE is what? V sub C minus V sub E. Okay. And then I sub E is equal to V sub E divided, maybe R sub E, like this one, I sub E here. Okay. It's like this one here. Okay. All right. So now, oh, and then the power, the distribution power, the formula for this case, I sub C, the collector current, like this one. Okay. I sub C multiply V sub CE. I sub C is equal to V sub CE. What is for V sub CE? Just like this one here. Okay, this is the V sub CE. Like this one. So what distribution power is equal to I sub C multiply V sub CE. And then to draw the load line and the Q point, we have to, let's say, we have to know I sub C saturation. Oops. I sub C saturation is V sub CC over R sub C plus R sub E. So go back to the circuit. V sub C is the voltage supply from the side of the collector, and R sub C right there, and R sub E just right there. So that is the formula for, which is to calculate a saturation collector to current. And also to, make a generated the load line, we have to know about the V sub CE, the cutoff. That should be the same, V sub CC, like this one. So the load line, this is I sub C, 0, V sub CE, okay? That's very important, okay? Very important means it's really similar questions for the second exam, okay? So right there, let's see, that was what? Like this one, I sub C saturations, therefore V sub CC over R sub C plus R sub E. And that one is for cutoff V sub CE is equal to V sub CE. And then some Q point, the Q point is what? V sub CE and I sub C. V sub CE and I sub C, we can calculate it from here. Okay, this is the V sub CE and I sub C. So after we find the I sub E, we can find it like this one. Okay, so that was the Q point here. So from the questions, I can ask you, what is the road line? How can you, please draw the road line, then you can find the Q point. Well, you can do this, right? Okay. All right. So any questions? Okay, so we will try to one sample exam, okay, for the emitter bias. The transistor circuit. Okay. V sub CC. God bless. All right. So that was R sub E, 1.2 k ohm, and V sub BB, 5 volt, V sub CC, 15 volt, R sub C is 2.2 k ohm. Okay. All right. There, that is a C, E, and B. And V sub BE is equal to 0.7. So the question is, what is V sub B? And the question is, what is V sub E? The question is, what is I sub C? And what is the I sub E? And what is for V sub C? And what is for V sub CE? And what is for P sub D? And what is for the load line? Okay. And what is the Q point? All right. So about 10 minutes. Okay. I'm gonna drink for you, but just for 10 minutes to try. And so if you have any questions, please let me know. Okay.
You might. What we got here? Hey. That was little tomorrow, and there's not in the lab tomorrow. Tomorrow's the lab. I wouldn't, put it past on the bottom either. Which could mean. I love this one, man. I don't want to keep up with this stuff, but it's getting kind of complicated with flip flops. Yeah. Yeah, I just. Yeah, it's not horrible internet now, makes that look hard to do honest. My friend actually Darwin. Really? Yeah, I'll link you with that. Yeah. Is it actually good? Yeah. It's probably good. It's a lot. I mean, like it's a satellite, isn't it? Yeah. Satellite internet is delayed as well. I'm sorry. Starlink's good. We only have phone service. You tried satellite internet for a little while, but it was 1.5 cents. That's terrible. Yeah. We were about 100-year-old. Yeah, we were paying about 150 a month for it.
That's what I'm saying.
I do not. It's a 2-story house. How in the name of God is a 2-story house a mansion? What's wrong with my chair?
Are you okay?
Yeah, my chair is just kind of screwed.
Don't worry.
What power dissipation where? Like total power dissipation?
Yeah.
Okay.
Oh, that's
What
sad.
is
You decided that you contributed.
Oh, yeah. Okay, I see.
By making the idea, flip the chair.
All right. So now we will try to calculate it for 9 questions. Any volunteer or the Hollies, are you okay? No.
Yeah, I'm good.
I'm good. Okay. All right. Okay, probably. All right. So I will do for you. So the V sub B is for that point. Okay. Like this one. There is the red, there is ground. What is the B? So V sub B is equal to V sub BB. You understand what I mean? That point, same voltage. So the V sub BB is equal to V sub B. So that is 5 volt. Okay. Any question? I'm gonna more small and something up. All right. Any question is fine, right? And then the second question is what is for V sub E? So V sub E, we learned before this formula is for this case is for V sub B minus V sub BE. So V sub B, we have already calculated 5 volt, and V sub BE, that is the second approximation diode. So the silicon 0.7 for 4.3 volt. Okay, 4.3 volt. Okay. All right. And any question? Okay. So next one, I sub C. Okay. So I sub C is, as we learned before, really similar to I sub E because the I sub B is right there. I sub B is very small, the almost 0. So this is why I sub C is almost equal to I sub E. So to find I sub E, that was like this one here, I sub E. So that was V sub E divided R sub E. So V sub E divided R sub E, 1.2 kilo ohm here. And we have already calculated V sub E right there. Plug in. So 4.3 volt divided 1.2 kilo ohm here. Finally, 3.58 milliamp. Okay. Don't confusing for the unit because the several student has the same mistake in the exam. So this is why, okay? 3.58 milliamp. All right. Okay. So next one, okay, next one is for what is I sub E? We have already calculated here. So 3.58 milliamp. And question 5 is for what is for V sub C? V sub C is V sub CC minus V sub RC. So here, that is V sub C part here, and V sub C is V sub CC minus I sub C times R sub C. So V sub CC minus I sub C times R sub C. For this case, 15 volt minus 3.58 milliamp times 2.2 kilo ohm here. Finally, 7.12 volt. Okay. All right. Okay. Any questions? Okay. All right. So the question six, what is for V sub CE? What is for V sub CE? The V sub CE is V sub C minus V sub E. We have already calculated, V sub C and the V sub E, okay? V sub C right there and V sub E right there. So V sub C, 7.12 minus 4.3 volt. So 2.82 volt. Okay. Approximately, 3 volt. Doesn't matter. All right. So next one, question 6. The dispersion power, same thing. I sub C multiply V sub CE, and the I sub C we have already calculated 3.58 milliamp. Multiply V sub CE is 2.82 volt. So now that was let's say 3.58 multiply 2.82. It was almost a 10 milliwatts, right? Because can you see that right there? Milliamp. God bless you. Milliwatt. So bless you too. No problem. It's free. All right. So the piece of tea. And then to draw the road line, we have to find I sub C saturation. Why? Because the road line, we have to find the two things. One is this one, that's one to draw the X and axis. Okay. So V sub CC is equal to V sub CC over R sub C plus R sub E, and V sub CE cutoff the same, V sub CC. So V sub CC, go back to the circuit, there's the 15, and R sub C, R sub E, 3.4 K ohm. V sub CC is what? V sub CC, 15 volt. Oops. 15 volt. Okay. So that is the 15 volt. Oops. So 15, the divided 3.4. Okay. 4.4 milliamp. Okay. Okay. So now load line 0, I sub C, and V sub CE. That point, V sub CE cutoff. And that point is what? I sub C saturation. That is a 4.4 milliamp. That was 15 volt. And then maybe this, okay, that was the load line. That is the load line. Okay. And then that was the Q point. That was the Q point. The Q point, I sub C and V sub CE. So what is it? I sub C, go back to the questions 3. 3.58 milliamp. 3.58 milliamp. And V sub CE, go back to question 6, approximately 3 volt. Okay. Approximately 3 volt. Okay, that is the answer. Q point. This is the load line. Okay. It's the load line. Okay. All right. Any questions? I strongly recommend when you go back to your home, you have to practice and then read the books. Okay. So honestly, it was impossible to understand just only from my class. Okay.
So for Q point, we use the calculated, like our regular,
IC and V sub C. Yes.
but the load line, we use IC saturated and VCE cutoff.
Yep.
Okay.
Perfect. Thank you. Yep. All right. Okay. Okay. We have almost done. Almost done. All right. So now we have the last parts of the transistor circuit. That is the voltage divider bias. The voltage divider, the bias. Okay. So voltage divider bias. So that circuit, that the transistor circuit is one of the really widely used, in the industry, you know what I mean? The biasing circuit. So I wanted to notice that was the base circuit has contained a voltage divider. We want to R sub 1 and R sub 2. I'm gonna drawing for you. Like this one. This is the V sub CC plus. That was R sub C. That was R sub E here. And then that was for B collector, emitter. This is R sub 1 plus minus voltage drop here. This is R sub 2 voltage drop here, like this one. Okay, so that was base, collector, and emitter. Okay. Base, collector, emitter. That was what? V sub CE, I sub C, I sub B, I sub E here. Okay. So any design of the, the voltage divider base circuit, the base current is much smaller than current through voltage divider rule. So if you have just collector part, I mean, like this one, that part here, I'm gonna removing here. That was V sub CC plus. That was R sub 1 plus and minus, and plus V sub BB, right? And that was R sub 2 plus minus voltage drop. That was the ground. So the V sub BB, the V sub BB means like this one, V sub BB is equal to V sub B, right? So V sub BB, do you remember R sub 1 plus R sub 2 over R sub 2 multiply V sub CC? Okay, that's very important. Okay, so V sub CC was given, it's right there. That was given. And R sub 1, R sub 2, the voltage divider rule, and then the base circuit to connect to the ground here, right? So let's say like this one. So this is why R sub 2, the ground connection, R sub 2 over R sub 1 plus R sub 2 multiply V sub CC. Okay. So there is one. All right. So that means the V sub B is equal to V sub R sub 2. Okay. Okay. And then V sub E is equal to same thing. V sub B minus V sub BE. That's right there. V sub E. It's right there. I'm gonna do another color for you. Let's say. Oops. Just right there. V sub E. Okay. That is V sub BE. Okay. So this is why. V sub E is equal to V sub B minus V sub BE. So the V sub BE is equal to 0.7 volt. Okay. And then same thing, I sub C is equal to I sub E. Okay, because the I sub B, well, to remove this one. So the I sub B is really small. So this is why I sub C, I sub E is really similar. Okay. And I sub E, same thing. In the previous transistor circuit, the emitter bias, we sub what? We sub E, the divided the R sub E. Okay. And then we sub R sub C, just right there. Here. We sub R sub C is I sub C times the R sub C. Okay. And then V sub C here, V sub CC minus I sub C times the R sub C. Okay. And then V sub CE, the voltage at the collector and emitter, very easy. V sub C minus V sub E, because we have already calculated before. I mean, we have already known, right? It's right there. And then the same thing, the distributed power, the P sub D, I sub C, the times V sub CE. Okay. And then to draw the road line, I sub C saturation for the VSD, it's like same thing, R sub C plus R sub E over V sub CC. And then V sub CE, the cutoff, same thing, V sub CC. Yeah. All right. So I know it's still confusing, the some of them. And I strongly recommend you back to the books. I think the chapter 6 or 7. So our midterm, we have the chapter 5 and chapter 6. So I think next week we'll finish for chapter 6, and after that I'm gonna read the review of the chapter 5 and chapter 6 for the second exam. Okay. All right. Any question?